what would we do in ANSYS? So you would have seen this cylinder block. If you have a gear two-wheeler, you would see this uh, engine which is visible to us. So when you look at this engine block, you would see this fins on the structures. So the fin and structure is used to dissipate heat. So why do you think it is heated? Because here within this is where combustion happens. So as you have this combustion taking place, you would have this cylinder block which is like being heated. So to dissipate the heat, they come up with the structure called like the fin like structure. So the fins are generally used to dissipate heat. So the heat being developed due to combustion. So in this case, we are saying that within this region is where combustion happens, and you're gonna see how effective is the fins, how effective the fins are, how effectively it can transfer the heat from this region to the environment. So the importance of the fins would be discussed, and thermal analysis on the cinder block would be carried out here. What else could we do? You again, when you have a two-wheeler, you would have come across disc brakes. So disc brake is generally used to stop your vehicle, and it has a different mechanism. So the whole point of using a disc the importance of using an effective disc brake is to dissipate heat. So whenever you hit a brake, that has been like when the brake pad comes in contact with the disc, and uh, what you're going to see there is due to the friction, frictional heat has been developed, which is nothing but high temperature has been developed. We don't want that heat to stay there. If it's going to stay there, your part is going to fail due to high heat developed. uh, so to despite that, you will have to come up with a better disc brake design. So disc brake design here, when you look at this, this pretty much looks good. The reason is because you have a lot of slots going here. So the importance of slots is here is to dissipate the heat which is being developed. So uh, uh, let's consider a disc brake without none of these slots. uh, it, the heat dissipation is going to be very less if it's going to stay there, and your part is going to fail. We don't want that to happen. So the importance of design will be discussed, and you'll be running simulations like this. And even if needed, this is a really good project work you can come up with. You can come up with a good design of your disc brake. Play around with the materials. You can use different materials. At the end of the day, you need to have a effective disc brake which can dissipate heat. So when you look at this brake designs, you will see a lot of designs. But once you have all those designs, you'll have to use ANSYS, run these thermal analysis on them to see whether or not it is effective or not. So that is what you'll be doing here. You'll be using different designs of a disc brake. You use different materials, play around with it, and come up with the best design for your part. So as a whole, dissipating the heat is one important aspect of disc brake, and that is what we would do. Okay, so with that said, I'll move on to the next part, which we call as implicit versus explicit. So when it comes to implicit, and just to give you a good example, you can see this video again. Uh, Implicit dynamics, it involves low velocity. Let's say low velocity, or you can even say it as long time event. Uh, that would be like a basic structural analysis, static analysis we do. But when it comes to explicit, we are talking about high velocity and a short time event. So one here, a good example down here is the bullet perforating into a material. So this happens with high velocity and at a short event, and even running a crash test uh, with your vehicle is one of an explicit dynamic task. So uh, this is the difference you see. And the basic analysis you do, low velocity, small, long event uh, stuffs you do, we call it as implicit analysis, and explicit dynamics or analysis is to do with high velocity stuff, short time event. So a good example is the crash test, impact test, dynamic test. So we would do run few crash test simulations. That's one part. You would be even doing bullet perforating dynamic response simulations like this. And one other interesting simulation which you would do in the class would be this bowling simulation. So it's just like you'll be simulating a bowling stuff, just like you'll have this pin, you have the ball, and you'll be simulating a bowling simulation. So this is one interesting simulation which we would do, other than the crash test or the bullet test, like bullet perforating to a material stuff. So I always find simulations like this so interesting. It is just thinking uh, totally different. I know we were talking more technical stuffs for all things, like taking some automotive examples, industrial examples, but I thought this would be something different from what we do. And this is one good interesting simulation we would run as a part of impact analysis. So that is what I had for as an overview for today's class. Thanks, guys. So I hope I covered most part which I have, which